you will get removed. All right, there we go. Let's get started. Today's session, I have pinned the links to the Code Lab, the Discord channel, and the result submission portal in the chat. Please, I've also pinned it twice. Please make sure you copy it and make sure you have the Code Lab open. Let me share my screen. All right. So today's session is all about building a simple agentic system with HTAP in AlloyDB. So what is HTAP? It's hybrid transactional and analytical processing. It's all normal. You must be thinking this is not new. What is agentic about it? We have done transactional applications in the past. We've built analytical applications in the past. That is true. It's just that the way we are unifying the data from dark status, like what we did in session 1 of the season, is uploading 400 PDFs, unstructured, raw, highly multimodal PDFs into your cloud storage. And we use knowledge catalog to infer them, semantically infer the relationship and the context in the data and translate them into structured tables with rows and columns and store them in BigQuery, if you remember. And in session 2, what we did is we use the data that is there in BigQuery. We federated BigQuery data through SQL statements in AlloyDB. Why did we do that? Because in today's session, you will understand that we will perform some transactions, the data for which will be stored in AlloyDB, and potentially in the rest of these sessions this season, they'll also be retrieved and used as transactional data within the scope of our agentic system, while we are able to fetch the data that is coming in from the analytics database, the data warehouse, which is BigQuery, which is your unstructured PDFs. So the PDFs contain the recipes, ingredients, the allergens causing ingredients, and the relationship between these ingredients and the suppliers for these ingredients, and the supplier manuals that contained further ingredients of those high-level ingredients that were present in your original recipes, and so on and so forth. So this was like a highly nested data source in the form of bulk PDF files, which we translated and stored in our data warehouse. Why was this in our data warehouse? Because normally, if you go to a storefront, they're not going to be handing you out the supplier manual of the recipe, right? You go and ask for a soft serve or a cone or a vanilla cone or whatever it is that you order. You're just going to ask for it unless you specifically say that I have so and so issues. I don't want to have this ingredient in my dish. Can you show me, or can you tell me if this contains so and so allergen? Only then, even then, if they have the information readily, they'll give that information to you. If they don't know or they're not aware of the specific allergen that you're asking for, they'll dig the supplier manual and other details. I don't know if you've had that experience. I've had that experience myself, because traveling around, I have had the need to ask if it's truly vegetarian, if it meant that if it was there was no allergen in it that I don't want to use, if there is no gluten in it. So there were like too many details that I was particularly concerned about, and they ended up handing me the manual, which I had to look myself to see whether or not I could order something. So this is not something that storefronts normally hand out. So that's why this is analytical data, not just for analytics. It is used for highly detailed insights. You probably want to run some metrics on top of the data that you already have. You probably want to create a knowledge base, so on and so forth. So that's exactly why we store it in our warehouse. In the meantime, our transactional database was AlloyDB, and we used the data from our warehouse through federated queries in AlloyDB, which we completed in sessions 1 and 2 this season. In this session particularly, what we are going to do is we're going to build a simple agentic application which uses an integration layer, which is MCP Toolbox for databases, which is also not new to many of you, because you have been if you've been attending Code Vipassana regularly, you would have heard this service, which is an open source free integration layer that is Google's open source service, which is available for you to use for your agentic applications. But even if you're new, that's totally fine. We'll talk about it. We'll understand what it is and how to use MCP, so MCP Toolbox for databases in your applications. So we'll be using MCP Toolbox for databases in our application today to talk to the unified data source. Why is this a unified data source? This is the first time we are doing this. In the past, we would have used AlloyDB, BigQuery, MongoDB, cloud storage, so on and so forth. But each one of these data sources existed as individual data sources through our, and the tools that were the front of these data sources were accessed by the integration layer, which is MCP Toolbox for your agent. So this was how we implemented MCP Toolbox always in the past. In this season, this is the first session we are using it in a unified data source format. Why is this a unified data source format? Because we already access BigQuery data through federated SQL in AlloyDB. So with MCP Toolbox, you're just going to talk to AlloyDB now, meaning connection-wise. You're just going to connect to AlloyDB, and you will still be able to pull the required analytics data from your warehouse through federated queries from our MCP Toolbox. All of this is to talk to your tool, is for your agent to talk to your tool whenever required. So that's what we're going to do today with MCP Toolbox. And why have we decoupled this layer from our agent? This we have addressed so many times. I personally like my agent to just do the job of the agent and not be concerned with database connections and talking to the database layer tool by tool. Of course, the tools are required, and the agent will, it is important for the agent to classify and access the tool as required. However, the agent should not be the platform or the layer that is hosting the tools to begin with, that is like sourcing the tools to begin with, because that becomes an overhead. Because if you need to change something in one of the tools, then you're changing the entire agentic logic, or not the logic per se, at least the application is getting modified and you will have to deploy everything all over again. So why go through all that when your tools can exist completely independently from the rest of your application, which is agentic in nature? So that's exactly why we are. Not just that, you will also be able to provide tool level security on top of the already available security security layers that your databases, in this case AlloyDB and BigQuery, provide. Those are already there. On top of that, you will be able to provide tool level security and other things using MCP Toolbox. However, that's not the focus of our demonstration today. We are going to be building an agent that talks to MCP Toolbox, which is the orchestration layer for your tools. And our main goal here is to access this unified data through your MCP Toolbox from your agent. That's all we are going to do. So let's look at what MCP Toolbox is. Like I already said, it's a unification or orchestration layer that allows your agent to talk to tools. Now, is that all MCP Toolbox is capable of? Is it only for agentic applications? No, you can use it in any application, even if there is no AI involved in your business or in your app, which is very minimal these days. Almost everything contains AI, even for calculator. Um, People are using AI for some reason, because that's the rush. That's how everyone is panicking, because if AI is not being used in it, it's probably not valued, is the mindset. However, that's not the approach. But I'm just exaggerating this to prove a point that MCP Toolbox goes beyond even agentic applications. You can use it in any standalone application also. It's an orchestration layer that brings your tools to your application. So these tools are database tools in nature, not just database tools. It can also be endpoints or files that are exposed. Any source that can be exposed as a REST endpoint can be hosted by your MCP Toolbox as a tool. So whether it's AlloyDB or BigQuery or MongoDB, or let's say cloud storage exposed through an endpoint, or my CSV files, which I have just written a cloud function to read, a Python cloud run function to read my CSV files and return something. Even that can be exposed as a tool if you're willing to expose that as a REST endpoint. Why? Even with security, of course, you would provision the tool level security. Now, why would it be required for you to expose an unstructured data or some file as a REST endpoint or as a tool through MCP Toolbox? Because it allows you to bring the necessary tools to your agent without the agent having to individually talk to multiple APIs and multiple data sources, you have your orchestration layer, which is MCP Toolbox, lifting that heavy weight for you. At the same time, you can query structured data, semi-structured data, and unstructured data in the same scale, in the same pane of glass, without whether you're writing SQL queries or you're writing a JSON payload to extract information. You can do it both in the same scale, meaning within the same YAML file, you can get both of these things done. So I can be querying invoice data from my relational database, which is AlloyDB, while I can be extracting JSON information for other attributes and price details from my MongoDB database, just JSON database, for example, a document database like Firestore, for that matter, all in one YAML file, but both in a single hit to your MCP Toolbox endpoint. So that's exactly why this layer is super helpful for enterprise applications. I use MCP Toolbox in almost all of my agentic applications, not just for demonstration purposes, even for my own architectural simplification and convenience. MCP Toolbox takes the load off of the agent. So I personally like it, and I would recommend it if anyone's looking for or designing a brand new agentic architecture, or is rehauling something that's already built out last year. Consider MCP Toolbox. It's also available for most of the golden languages, Python, Java, Go, and all that. So anyway, that's MCP Toolbox. HTAP, I already said, it's hybrid transactional and analytical processing. Inherently, AlloyDB is capable of doing HTAP, which is both transactional and analytical processing. Even without query federation or data federation, individually, AlloyDB is capable of handling both transactional and analytical workloads, just because of its super fast transactional and analytical processing capabilities, and also low latency and highly efficient columnar engine. So that's exactly why AlloyDB is inherently capable of HTAP. I have previously used AlloyDB even without any federation as both transactional and analytical system. But in this session today, we are going to use the unified data source, which is accessing transactional data from AlloyDB and federated analytical data from BigQuery through AlloyDB, all in just one query from your MCP Toolbox for databases, access from your agentic application. All right, so this is just the background. Now to get started, again, in this session too, since we are not getting started with billing account or any of those hassles, all you have to just do is get started with creating a project or use an existing project, and that's pretty much it. I'll just quickly recap the data that we have already set up. You don't have to do the data setup again, because there is another way I have made sure that you're able to access the data this time. You don't have to create another BigQuery data set in this session. We'll just jump straight to the application, but I'll demonstrate all the steps one by one so you're aware. But I'll tell you at which part you get hands-on. To begin with, you get hands-on in the first step number 2. We have already completed step number 1, which is overview. We just discussed that. So before I get into step 2, which is the enabling the project and Cloud Shell and other things, I just want to pause really quickly and ask everyone if you understand what we're talking about, and we can continue to the next step. All right, perfect. Thank you for the confirmation. Yeah, all good questions. I'll get to that in a bit. Let's move on first to the project creation, and then we'll have a lot of time today as well. Right? So let's get to step number 2, which is before you begin. So please make sure you have the code lab open, and also open a tab. Make sure you're logged in from your personal Gmail account, and make sure you're logging into console.cloud.google.com. So I'll ping the link here in the chat. Go to console.cloud.google.com. For folks who want to use an existing project that you have been using for the rest of the sessions this season, please continue. For new folks who have not created or you have created a new login or new account and you want to use a brand new project, or you've never used Google Cloud before, this is the first time you're using it and you want to create a project, then you follow what I'm instructing right now. You see right next to the Google Cloud logo in console.cloud.google.com, next to the Google Cloud logo, you will see an open project picker drop down with the three hexagonal shaped dots. You will not see any project right there. So click that project picker and you will see new project dialog box. Click the new project button in the top right corner and you will see project name and organization. Leave everything else default. Only the project name needs to be changed to whatever you want to call it. You can just say Code Vipassana Season 15 ABC, or you can just say Agentic Application Froyo or Froyo Store Manager, whatever it is. Just name the project to something that's long enough that it does not attach any extra numbers in the end for an ID. Yeah. And then scroll down and click the create button. Don't worry if it shows or if it is not showing billing account or anything. Don't worry about that. Just enter the project name and click the create button. It will take a few seconds and it will create the project. I'm not going to create one because I already have an existing project and I'm going to continue to use that. Click the Google Cloud logo and come back to the home page, that is the console, and make sure the newly created project is showing in your project picker dropdown. Show of thumbs. How many of you completed project creation? Perfect. Thank you. All right. Going back to our code lab, we have actively actively created a project or use an existing project. Make sure you're in the console. And right next to the search bar, you see the Gemini Cloud Assist icon. And right next to that, you have Activate Cloud Shell button. Go ahead and click that button. You will see Cloud Shell terminal initializing. It will take a few more minutes, extra minutes, if you're opening it after a long time or you're opening it for a first time. It will take some time to load. Allow it a minute or a few seconds. It will ask you to authorize. Go ahead and authorize. By the end of initialization, you should see what you're seeing in my screen, which is Cloud Shell terminal with your account ID followed by your project ID showing here. Now, project ID is different from project name. If you want to get your project ID, which is required in this session because you will use that project ID in the application that you're going to build. So click the project picker drop down in the console that you see. And against your project ID, project name, on the right-hand side, you'll see its ID. So make sure you copy this ID and paste it somewhere, keep it handy so that you can use it in the agent when it's required. Just keep the project ID handy. In the meantime, make sure your project ID is showing in this Cloud Shell terminal. If it is not showing, then you have to enter the command that is right above that line. If you see right above the current prompt in the terminal, it is showing use gcloud config set project ID to change to a different project. So that command is exactly what you need to use. Gcloud config set project and your project ID. Enter your project ID and hit enter. This will actively set your project ID in the current Cloud Shell terminal. If you're still wondering how to get your project ID, right next to Google Cloud Console, you see the project picker drop down right here. Click that, and on the right-hand side, you will see the ID. Copy that and keep it handy. Show of thumbs only if you activated the Cloud Shell and make sure your ID is showing. Awesome. Okay, now that everything is enabled, you will not need to enable these APIs today because Your job is to create the agentic application, and I've made sure the uh, IDs and stuff, the data is actually readily available for you in the repository in the form of CSVs. So you're not using AlloyDB or BigQuery, although we did cover them in the first two sessions. So we've already created the data there. Don't worry if you didn't attend those sessions, just know that we converted unstructured data, that is PDF files, to BigQuery tables, rows and columns using knowledge catalog and semantic inference. And in the second session, we federated it into AlloyDB. So we have data there, all right, in both those places. In this case, I have made available all of this data that you would need for today's application within the repository itself. So you don't have to worry about going back and putting the data there right now. If you have time later, please go through session 1 and 2's recording or the code lab. It's pretty detailed. All right, now step number 3, preparing the data. Why is this additional data required here? Because remember I told you, we are bringing in AlloyDB as a HTAP here because we can directly use BigQuery, but then we have some transactional data that is going to be stored in AlloyDB, which is order processing, right? You need to, this is the storefront manager agent that you're going, the Froyo storefront agent manager you're going to build. So it is going to be able to take orders. So taking order is a transaction. It is not just what is the recipe, what is the ingredient. It's not just data warehouse data. It is actually transactional data too, right? So since the first two sessions covered analytical data or warehouse data, this session, we are going to include this new table in AlloyDB, which is live orders. This table will contain order ID, customer name, product ID, quantity, order status, and created at. This is a normal AlloyDB table, which you can just run to create. The order ID is kept at serial because it will automatically run it'll automatically increase the serial number of the order on its own so that you don't have to put that in. It's an auto count, that's why. So now if I have to go to AlloyDB and show you this, let me just quickly open that. I had it open here, yeah. So I'll go to AlloyDB instance. Connect to AlloyDB Studio. You don't have to do this step. Just hold on until we are ready to write the application code, okay? You're just watching me set or create this new table in AlloyDB. All right. Since I already have this table, I'm going to call it live orders 1. All right, there we go. The table is created and we are ready to move on. What else are we doing? We are just preparing this data. So now this does not mean the current application only uses live orders. The agent that we are going to build is using live orders. On top of that, it is going to use all those eight tables that we created in the first two sessions of this lab. So how are we, of this season, sorry. So how are you going to get access to all those tables? I'll tell that in a bit. It is there in our repository. We'll go to that step in just a couple of steps. Moving on, now that we have all the data in place, assuming that you have the BigQuery data, which is the analytics data, assuming that we have the transactional table that is created in AlloyDB, and assuming that the federation is enabled in AlloyDB to access BigQuery data, now, like I said, it is time to define the abstraction. Remember, I said we are going to use MCP Toolbox in order to set the orchestration between your agents and your data sources. So we are going to define the MCP Toolbox right now. So MCP Toolbox, like I said, is an open source service that helps agents talk to tools that are coming from databases. So how is it going to enable that? Just a simple YAML file. This YAML file will contain all of your data sources, all different databases, different formats, structures, everything. In our case, like I said, we have access to a unified data source, which is AlloyDB. Both AlloyDB data and BigQuery data can be accessed through AlloyDB. And like I said, we are going to build a Froyo store manager, a storefront agent, which means we require 2 agents mainly. We can have multiple agents, but I'm going, multiple tools, but I'm going to use only 2 tools today, just for the sake of simplified execution. One is checking allergens. Remember how we checked allergens in BigQuery, whether this Froyo product has so and so allergen or does it have any allergen, for example. So that is one question, one tool, check allergens. And the second tool is place order. So I'm fine with this. I want this product. Now go ahead and order for me. So these are the two tools that I'm going to use today in my agent, a simple agentic application. So MCP Toolbox connects to this data source by looking at this AlloyDB source definition here. You don't have to hard code this. Since this is a demo application, I've hard coded. Ideally, you would use secrets or environment variables to pass in the values for this. And you can also set tool level security. In this case, I have not maintained a tool level security. We have code labs in the past season where we have demonstrated tool level security for one of the Java based MCP Toolbox implementations. In this session, we are just focusing on the unified data source access. So tool number one, check allergens. Like I said, this is going to query BigQuery tables, but from AlloyDB because we are federating it. So what is the query? Simple, same query that we used in the last session. What it's going to do, it's going to take the allergens table against product, against whether the ingredient table, and against the table that checks whether a particular ingredient contains allergen or not. That's all. And it will take user's question, user's product that the user is inquiring about, that as the input, as the product name, and it'll compare this against the product name in the database, and it'll get this required result for us. So this is actually accessing the warehouse data. This is not a transactional data. However, we are accessing it from the unified data source, which is in AlloyDB through MCP Toolbox. The second tool is straightforward. It's a transactional tool. If you look at it, insert into live orders. Live orders, like I showed you, I just created this table. It's a simple transactional table. It stores customer name, product ID, quantity. That's all. And everything else is auto-populated field. So it'll just populate the fields. That's pretty much it. It'll take user's name and the product that the product that the user wants will be provided as a name, as the product name. This query then goes in and picks the product ID from the table, and then it populates here. That's pretty simple. Any transaction, however you do your regular transaction, it's just the same. Nothing new here. But just know that we are accessing two levels of transactional and analytical data queries or tools directly from a unified data source from MCP Toolbox. All right. So now we are going to look at how this toolbox is deployed as an individual service that the agent can use. Show of thumbs, you got this point, and then we'll move on to a question. I have a question for you all now. So why do you think we have already established that we have 400 PDF files? Why can't I build the agent on top of those files directly, unstructured data? Why can't you just build a file? Build an agent on top of that? You all know the kind of questions we're asking this agent. It will hallucinate. Okay, what else? Token limit issue, timing, latency, hallucinate, does not loop through, data density, timing. It will confuse if you change the structure or something. Prevent unnecessary SQL insertion, token issue, data structure. All right, so our LLMs are inherently capable of handling unstructured data. And also with the amount of context window that we have right now, I'm not saying pass 400 or 1,000 PDFs at one shot and then get it to work. That's not what I'm suggesting at all. But even then, unstructured data is maybe possible. But yes, your answers are all correct. One is definitely there will be latency issue if you're trying to, if the data is not found in the top few files, it'll end up having to look through all of your files, all of the data that's available in the unstructured heap of files that you have. And of course, there is token, there is quota, like token limit issues. And of course, there are other issues like hallucination. Why will hallucination come into play? Because first of all, it will look at, let's say if you ask about a product named a swirl, just what do you call it? Midnight swirl or something like that, right? Soft serve. Let's say something that we all know, a soft serve, right? So if you're asking for a softie and it says, okay, here is the PDF file for the recipe for soft serve, and it will have a user manual, sorry, a supplier manual that contains an item called ABC. This is an ingredient. Let's say FOS or ABC, something like that, is an ingredient that is listed here in your recipe book, but you don't know what that recipe, what that particular ingredient contains, what allergen that particular ingredient contains, right? Not even an LLM, not just you. Even an LLM that's highly capable will not be able to make that inherent connection, knowing that this PDF is linked to this PDF, unless you explicitly prompt, hey, this ABC or FOS might also be present as user manuals, or might also be present as supplier manuals in another PDF. Go and look there and find out whether this really has any allergen or not. Don't just look at high level ingredients right now. So if your prompt is this detailed, then yes, that could work. Or if your PDF is that detailed that your PDF is inherently linking, like hyperlinking to another PDF, maybe, I don't know if all LLMs support hyperlinks or not, but maybe that's a possibility. However, if you had the time and resources um, to take the effort that it requires to do all of that across all of your 1,000 PDFs that you have for your warehouse, then you would not need for an agentic solution at all if you had that much of resource then. But that's not the scenario. We want ultra fast solutions. In most of the cases, the PDFs are not marked. The data is not linked. You don't know which is the supplier manual that you need to look. You cannot manually parse through all of those things. So in essence, all of your answers were absolutely accurate. This is exactly why we cannot directly process them. And this is exactly why we need the agent to be talking to a unified or a structured or even semi-structured is fine. But some form of relationship, some form of inference had to have been made in your files, across your files for you to be able to empower your agent to answer such questions. So that's exactly why we're doing this. I just don't want you to go through this session and be like, why did I have to do this? I didn't need this kind of thing. We are only solving problems that are absolute essentials for your business needs, not just because we need to show a demo, right? So moving on, now we have the tools.yaml ready. So how am I going to make sure this tools.yaml, in fact, gets exposed as a REST endpoint that my agent can talk to? So let's just go to what my code lab says in step 5. Go to step 5 in the code lab, deploying the toolbox to run. You don't have to execute this step as well. Your part comes in step number 6, which is the next step. So this step, you're still listening. So what I'm going to do is I'm going to follow step 5 of the code lab, which is toggle to the Cloud Shell terminal. All right, I have my Cloud Shell terminal right here, and navigate into the working directory by running the command cd froyo-agent. It's asking me to authorize. I go ahead and authorize. All right. Let me see if I have that file already. I don't, so I just make it as cd froyo-agent. Okay. I need to create that folder to begin with. I think it's cd froyo and -multi-agent. You need to create that. I missed that step, but yeah. Now that I have this multi-agent created, let's see. Yeah. So I am sure that I have all the files here. Once again, let me just see if I have. Sorry, I missed the step. In step 4, I have a few steps here. Go to your Cloud Shell terminal, toggle to editor mode. Okay, I'm in my Cloud Shell terminal, editor mode. Let it just load. The next step is create a new folder, which is froyo-agent. Inside the folder, I'll create tools.yaml. All right, so let me do that. I already have this tools.yaml right here, ready to go. So if you look at it, this is my tools.yaml. Whatever we saw right now in the code lab is exactly what is right here in the tools.yaml file. So the next step here is go to Cloud Shell terminal. Now I switch back and then I save this tools.yaml into a secret. Why do I do this? Because I need to hold this tools.yaml somewhere. You can store it in whichever way you want. You can just store this as an environment variable, but it will be a lengthy file. So it's better to keep it as a secret for long-term storage. You would need this if you're running and making changes in your environment. So better to store that as a secret and then export your image. You point your image to your Docker path, and then you go ahead and directly containerize and deploy it to Cloud Run in one single command. So this one, what this Cloud Shell command does is gcloud run deploy. This is a single command that packages, that is containerizes your source code, which is only tools.yaml, and your toolbox. Toolbox is installable, right? So, and it takes that one as well, which is what we are doing right here. We are taking latest toolbox installable, and you're just running gcloud run deploy. You're assigning the image variable to what you have stored right here, and then your service account is toolbox identity. You don't need to provide a service account if you're directly using your compute. Yeah, so which is a default service account which you could take. If you don't want, you don't have to give the service account, and then set up the region and make sure your set secrets has the latest tools.yaml. You can name the secret whatever you want in the previous step, and you assign it here. And then in the arguments, you pass tools.yaml, host and port address. And we need to have this in the same network and subnet as your AlloyDB. Because we have our tools, which is database, our data source is AlloyDB. AlloyDB has some network requirements. We have created our AlloyDB cluster and instance. If you remember from session 2, Friday's session, we created the cluster and instance in a specific VPC network, and you have to mention those names here because if you want to use tools from AlloyDB, your service should also be within the same network. So you have to mention that right here, network and subnet, and make it allow unauthenticated. I have made it allow unauthenticated so that this endpoint is accessible by any application or any user. However, in your production grade applications, you'll probably want to limit this by OAuth or any other security using service accounts. And VPC egress, we want to set that as well, and private ranges only. This is how we have defined our AlloyDB cluster and instance. So that's why we have to match some of the requirements here. But otherwise, the top 5 parameters are all pretty generic, boilerplate for all of the cloud toolbox deployments. We do the same thing. Now, these 3 steps are what gets your toolbox to Cloud Run. So where is toolbox? I didn't see toolbox at all. You just showed us a tools.yaml file. Great question. Tools.yaml is the source that you remember, you know that you'll see that in the next step shortly. You'll see how you're writing a Python file and then running it anyway for your agentic application. Similarly, for running or testing your toolbox from source, tools.yaml is your source file. So tools.yaml is your ultimate source for all the tools that you will be unifying through this MCP Toolbox instance. So where is Toolbox coming into play? What is Toolbox? How do I know its existence? That is the step point number 6 here. What we are doing here is we are taking the latest Toolbox binary. This means it takes the latest Toolbox binary from this location and it's assigning to the variable image. So the Toolbox's latest image is stored in the variable image, and that's what you're using here. So this knows to pick it by default, the latest version by default from where it's available. Now, if you want to test Toolbox locally, you need to go to Toolbox, MCP Toolbox for databases. And you have to download the binary from there, and you have to put it in your local working directory. I prefer to always deploy it in Cloud Run, because that way it is accessible for any application that I want to build further from there. And I can easily give access to someone to try test out the tools or use those tools in their application. But ideally, you will have to deploy it at some point. But while you are in development phase, you can just download Toolbox from here. Where is it? There, this one. You can just copy the install Toolbox setup. Where is it? There it is. Depending on what OS you have, you can just choose the one that you want, and you can typically you'll be using this if you're running it from Cloud Shell terminal, and you will install the binary locally. You will copy it locally. Basically, it's just copying the binary. That's all. I don't want to do that step because I can just handle it all and directly deploy it to Cloud Run. And I have already done that, and I have my Toolbox endpoint readily available. So how would I test it? I have my Toolbox working. If you try it, even you can use this endpoint, but I don't want to use it because I have made data available for you in the repository. All right. So if I go to Toolbox endpoint right now, it will it'll shortly show me hello world, which is just pinging the server and telling me it's active, nothing else. I just posted this message here to tell me by default. It's a default thing. It'll just tell you that it's active and it's running. That's pretty much it. But how to use it, only an agent will know. Meaning only your receiving application, whichever application is consuming this endpoint, will know how to use this tools that you have defined. You can test it visually also. All that is for another Toolbox specific day, but we have already discussed that. It's there in this documentation as well. I'll just drop this link in the chat so that if you're interested, you can just take a look at um, how to visually create a tool using MCP Toolbox. So many things that are possible with MCP Toolbox, but that can take a whole session in itself, but that's not our main. That is one of the main ingredients for the session today, for the whole orchestration today. However, that's not the only thing. We've got to talk about other components also. So I'll stop here, but just know I have created my tools.yaml and I went to Cloud Shell terminal and I stored my tools.yaml in a secret file. And I access the secret file and the toolbox binary in my gcloud run deploy command to get my toolbox deployed on Cloud Run. That's it. Now my toolbox endpoint is ready. I'm moving on to step 6. Now this is part of the step is something that you will all be able to do. So I'll tell you what this app.py is doing, and then we'll all clone the repository together. All right. Just before we go to that, I'll quickly explain what this app.py is doing, and then we'll go to the hands-on part. So with our database abstracted away with MCP Toolbox, which is tools abstracted away, our Python code is exclusively focusing on orchestrating with the tools for our agent and reasoning for the agent. That's it. So for agentic development, we are using Agent Development Kit alongside Flask. It's a Python Flask application using ADK. ADK provides enterprise-grade agentic experience, agentic orchestration, session, long-term, short-term memory, security, and native integration to Toolbox, and seamlessly gets deployed to Cloud Run as well. You can also deploy your agents to Agent Engine if you want to use any of the advanced features of ADK. We are not going to use any of those services like security or memory today, but we have done that in the previous seasons, season 14 and 13 of Code Vipassana. But this session is about using ADK to build a simple agentic system, which is a Froyo storefront manager, sorry. All right, so this is all the app.py is doing. So there is a link to the GitHub repository app.py. Click and go there. If you go to app.py, you can just see that right there. All that we're doing there, it's loading the environment variables to project ID, location, app name, user model, what model we are using, 2.5 Flash. Feel free to try out 3.5 Flash as well. I just thought for our minimal use case, 2.5 is enough for now. If you want to change it to 3.5, you can try it. You can extend this application to do other things as well. Toolbox URL, if you do end up deploying your own version of AlloyDB instances and making sure your data is available in toolbox endpoint, then replace this toolbox URL as well. And API key, we all have to get a Google API key, which is possible even without a billing account. So let's go ahead and do that. But before that, let me just finish walking you through. Here we are initializing Flask. And then here I'm calling toolboxes. I'm initializing the toolbox sync client with the endpoint that we've already deployed. And in the next step, I'm loading all the tools from toolbox. If you notice, our tools.yaml has two tools only. So I'm loading both the tools in this point. And here is my agent. All my agent is doing is acting as a Froyo store manager assistant. It has access to real-time transactional and federated analytical data. If a customer asks about allergens, use a specific tool. If a customer asks about placing an order, use another tool. Format your responses clearly, blah, 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 so on and so forth. All the operating protocols are given. We are actually using in-memory session service, but don't worry about it. That's not the focus for today. We are using in-memory session service, which means it will remember the user's preferences, um, all the user's preferences by default. So that's exactly what we're doing. And here we are testing out the initializing the session right here. And we're also testing out the we are also initializing the session right here. So in our case, we are routing it when you go to the application, straight to the application, the default route, it'll take you to the landing page, which is index.html. We'll look at it shortly. And once you start asking questions, it will go to the next route, which is chat. And each time you start chatting, it'll automatically um, uh, make sure your session is initialized, and it will retain the session in that in-memory session, and it'll go on and on until the session is complete. So that's why the session initialization was there previously. I hope you can connect the dots there. And then our run agent loop is able to start to run the agent, and it extracts the output from it, and it processes the response, and it sends back to the user once the agent run is complete for a specific run. There's a decent amount of logging that's done by the app as well. So please feel free to take a look at your logs if you want to understand more in detail. If something fails, or if you want to understand a step a little bit more in detail, you can also look at the logs explorer if you deploy it in Cloud Run or in your console logs. All right. So this is app.py. Going back to my Cloud Shell terminal, what we want to do here is I want you all to clone this repo so that we can test it out. All right. So go to your Cloud Shell terminal. If your Cloud Shell terminal timed out, it will ask you to reconnect. But before that, show of thumbs how many of you understood till this point and are ready to go to. Perfect. Thank you so much for confirming. Please go to your Cloud Shell terminal and do CD and hit enter. This means it will just change directory to your root of the workspace, and all you'll see is the your account followed by your project ID. You should be in the root of your workspace. All right, so now what I'm going to do is go to the code lab, copy the second step, which is git clone so and so. So copy that git clone line, come back and paste it here. Since I already have Froyo data, I'm going to store it in Froyo data 1. You don't have to do this if you don't have Froyo-data already. Just copy paste git clone and that repo link and hit enter. It should have cloned the entire repository into your Cloud Shell machine. You can see that by clicking open editor button on top. As you can see in my screen, click that and you should be toggled to your Cloud Shell editor. And if you refresh by clicking in the Explorer pane, if you hit the refresh button, you would be able to see the newly added Froyo-data folder. There it is. This is the one that I just cloned. Perfect. So you should all be able to see what you're seeing in the code lab, the screenshot. You should have index.html. You should have .env. You should have agent. Sorry, forget about the agent evals right now. That's for tomorrow's session. But look at the app-noble and app.py. And then you will see 9 CSV files. and 10, 11 CSV files in total. And then you will see requirements.txt and tools.yaml. Tools.yaml is just for your reference. Requirements.txt is something we'll look at shortly. But please note that these CSV files are made available for you. Where is it? Here on the left hand side, these 9 CSV and 11 CSV files are made available because you are not deploying MCP Toolbox at your end and you don't have access to the data because we deleted the AlloyDB instance in the previous sessions, or you probably never created one because we didn't start off creating a billing account and all that. So the data that we saw from the 400 PDFs, I have exported them into these CSVs, and these CSVs are cloned now in your repo, sorry, in your working directory. So you don't have to worry about changing anything or deploying Toolbox just for the demo purpose. Yeah. So now you can just make sure that the data is there, and meaning you don't have to do anything to make sure, just know that the data is there and your application would work, but not the app.py, because app.py requires MCP Toolbox endpoint. You're not going to do that. You're going to do app-no bill. This one was exclusively designed for using the data from CSV and not the MCP Toolbox endpoint. Your agent will still use the tools, but these tools are defined as functions as opposed to MCP Toolbox endpoints, just so you can actually experience the whole agent. All right. So just make sure the app.noble, we don't have to go through the app-noble code because it's pretty boilerplate, pretty simple Python application that exposes tools as functions, and the agent uses these functions directly as tools. So it's not function calling, it is actually tools, but it is indirectly functions and not MCP Toolbox tools. The reason we did that is so you can do it without building account. All right. So app-noble is your friend right now. That's the Python file that you're going to execute. But before that, there are a few things you need to do. If you go to .env file, you will see, if you can see my screen, you will see Google API key, MCP Toolbox server, and project ID. Forget about the MCP Toolbox server URL. Leave it as it is. In the Google API key, replace that with your API key if you already have one. If not, I'll show you right now how to create it. Project ID, remember I asked you to copy and save it somewhere so that you will use it in your application. Paste it here. So if you don't know how to find your project ID, go to your Google Cloud Console or the terminal that you're on. On the top left corner, you will see right next to Google Cloud logo, you will see Project Picker. Click that and you will see on the right hand side of your project name, you will see project ID. That is the ID that you need to replace in your .env file. All right. Sorry, .env, yeah, .env file under project ID. So that should replace your project ID. Now, what do we do for Google API key? I'm going to show you now, but before that, show of thumbs only if you got to this point. If you're not able to find .env, you will have to, there is a way to find it. Right click and or just do a search for .env and hit enter. By default, it hides dot files. Okay, if you can't save, just create one. Under that particular folder, your project root folder, right click, create a new file and say .env, it will automatically open. There is a way to open it. I can't remember now how I opened. Sorry, view. On the view menu, you should see toggle hidden files. That's how you'll see the .env. Go to view menu, toggle. Yeah, thanks, Jashwant. That's what I was going to say as well. Yeah, you can create .env manually also. Even if it's hidden, you can create it. It'll end up opening it. That's all. If not, just click view menu and go to toggle hidden files. All right. So now we are in our .env and we don't know what our Google API key is. Go to the code lab. If you scroll to step number 7 of the code lab, step number 7, the UI and running the app. Scroll down. We'll look at index.html in a bit. But scroll down under .env file populated section, there is a how to get your Google API key topic. So right below that line, you see a hyperlinked Google API key uh, phrase. Click that Google API key phrase. It should open a Medium blog. Scroll down. This blog is a short 5-point blog. It just tells you how to get your Google Gemini API key. So open that blog, right click that aistudio.google.link. I'll also paste this link here so you can follow along. Go to aistudio.google.com. All right, I'll open it in a new tab. Here we go. The next step, click the Get Started button. You should be seeing the Get Started button if it's the first time. Since I've been using it repeatedly, I don't have a Get Started button. On the bottom left corner, choose your Gmail account. So bottom left, this is the bottom left corner. Make sure you have your active Gmail account selected. Whichever one you're using, right? So use the Gmail account. Next step, click the Get API button on the left pane. It is towards the end of the list in the screenshot above. So right in the bottom left corner, in the Explorer pane, if you scroll up slightly, you would see Get API Key button. It's second from last, right above settings. Click Get API Key. And in the dialog box that opens, or in the page that opens, sorry, top right corner, see if you already have any listed API keys, you can copy that by clicking the Copy API Key button on the right. If not, if you don't have any, if you're brand new to aistudio.google.com, click the Create API Key button, as you can see in my screen on the top right corner. Click that, and you would see your, it will ask you to name your key. Just give a name. Just give a key name so that you can remember why you created this key. And then right below that, it'll ask you to import a Google Cloud project. Select the project that you're on right now. And then click Create Key. The moment you click Create Key, it will create the key and display it to you. You will have to copy it and save it somewhere. So that, don't save it somewhere, just use it in your environment variable, .env file. Just come to .env and replace the stars with the API key that you copied from there. That's it. That's how simple it is for you to get the API key. Show of thumbs, how many of you got your API keys? How many of you updated the .env, except for the toolbox endpoint, the other two? Perfect. So now we all have the API keys. Going back to the code lab, it also talks about in UI and running the app, the index.html. This is a very simple HTML just to give a good user experience. Very simple though. If you go to within the Froyo data folder that you're on, the project root directory, expand templates and click index.html. It's there. It's just a simple HTML, CSS, just a colorful one that greets the user in the front page with 3 different panels. One listing the top Froyo products that users generally order, and the middle pane will be your chat specific area, the agentic area where users ask questions, like the store manager relays the user question and the agent answers the store manager. And on the left hand side, you'll see your technical, like what servers are up, what servers are doing what purpose. That's all. That's pretty much a simple HTML. Yeah. And go to your requirements.txt file. If you go to requirements.txt in your root folder, you will see the Flask dependency. You'll see Google Gen AI. You'll see Google-ADK because we are using ADK. You'll see MCP. You'll see Toolbox-core because we are using MCP Toolbox. Toolbox-LangChain. You can use either one. I think we would have used core. I don't know why I included this dependency as well. Maybe I'm using both. Let me see. No, I'm just using Toolbox code. Anyway, I have included both for some reason. And then you have python.env to support your environment variables. And then you have Vertex AI. Although you are not using Vertex AI because of billing account, you don't have billing account. It's just that either this or your Google Gen AI, the Google API key. We're using API key anyways. But if you want to use like Vertex AI memory management or other capabilities of ADK, you can enable Vertex AI and import those dependencies in your Python.application, app.py application. And then we have pandas. This is mainly because we built the no-bill version of the app.py to support CSV files and support the processing of data in-house, like in the scope of the project. So that's pretty much it. Our project is essentially ready. Now let's go ahead and run the application. Ready? Go to your Cloud Shell terminal. Toggle between editor and terminal by clicking the Open Terminal button. And you should see no directory here. If there is a specific directory that you're inside, just come out of it by entering CD and hit enter. It will come to root. Now go ahead and do CD froyo-data, wherever it is you have the project. I named it differently, so don't worry about me, but others you would be able to. Yeah. First do CD froyo-data, and then you would be able to see the entire project structure, as you can see in my screen. All right. So now that we have everything ready and we are ready to test, go ahead and run the dependencies. Install the dependencies by running pip install -r requirements.txt. It's also there in the code lab. Just copy this line, this command, and hit enter. It's there in your code lab. And the next step is to execute the Python file. Don't run python app.py. It will compile, but it will not really, when you start chatting, it will fail because you don't have the MCP Toolbox endpoint. Do the other one, which is python app-nobil.py. Once the dependencies are installed, go back. Yeah, it's ready, no? So now run python app-nobil.py. It will take a moment. There it is. You will get a red warning, but that's okay. That's because you have used the logs in the console. You can change it to production with whatever changes you want to do, and then disabling all these console logs and turning off the debug mode and running all addresses on so and so. There is a link, there is a hyperlink for the app running on 127.0.0.1 Click that, the local host. It'll open a new tab and you should be able to see your application live. And on the left hand side, like I said, because this is a storefront portal, store managers portal, they should see if all the engines are up and running, right? If something is wrong, then they will not get the data. So they should be able to see the system status, Gemini check, AlloyDB Federation check, MCP Toolbox check. So now the agent is ready in the middle. And on the right hand side, the product catalog. This is for popular products getting listed. I mean, it's not really popular products. If you want, you can do advanced analytics queries and get the popular products here based on the usage. If you continuously use orders and other things, we can derive popular products based on the number of orders provided in a given week or a given month easily. But that's not what I've done. This is just listing some of the colorful products that had allergens in them so that we can actually interact and test it out. But feel free to extend this application on your own to add new features or modify this for your own purposes, for your own business or applications, right? So let's click one of these products. It'll say, can you check allergens for midnight swirl? Hit enter. There we go. The allergens for midnight swirl are, and it says soy. This is not hard coded. Even for your CSV files, it's actually coming in from agents and tools. It is actually going through the data and it's analyzing it for the minimal information that we have. We have only 4 products there in the right-hand side. So it is only doing that. So make sure you're able, it's only doing it for 5 CSV files. And these CSV files are already organized in the form of, if you look at the CSV files, it's actually very important for you to look at the CSV files right now. I'll tell you why. So if you go to Froyo data here, you have, it's also there in your repository. So feel free to go to editor and see that, but I'm going to just show here. I don't want to toggle off the terminal yet. So as you can see, it has allergen data, consists of, contains allergen, ingredient, product. So if you remember, these are the tables in BigQuery that we created from the unstructured database, unstructured set of PDF files, PDFs. If you gave your PDFs instead of this structured form of data that is CSVs, it will not be able to give this sorted answer just because our data was related, semantically inferred and referenced to other connections that it has, and also structured in the form of tables. I'm not saying unstructured or semi-structured data cannot be used for intelligence. I'm just saying you cannot make inference across multiple unstructured resources if you don't have a way of either storing them in a structured way or in a semi-structured way with the intelligent inferences done between them. So that's exactly what I'm saying. So if you go to Code Lab right now, the ultimate test, this is exactly, I think this is what you submit for the result this time. Let me just quickly check that before we take a poll of how many of you completed this step. This is session 3. You need to submit step 7, UI and running the app. Submit the screenshot of the agent app running in your local. Step 7. This is the one. You see right here, this is what you need to submit. The last screenshot of step 7 is what you need to submit for result today. All right, now going back to the code lab, we are in ultimate test. You click any product, any other product if you want. Only the list of products here is limited. The data, the CSV is not limited. If you open a CSV, file, not 400, and the related information. So you will actually be able to see denormalized data in the materialized view, and in other tables, you will be actually able to find the number of products that were there in the PDFs. However, this list right here is a short list, just so you can use it for testing. But whatever you're sending here, it's actually doing this analytics based on the inference that we already made with knowledge catalog and the data scan job that we ran from knowledge catalog. So it's saying vanilla flash has 2 allergens, tree nuts and almond. So how about we test it now? We've been checking all of these things for way long enough. Let's just go to our repository and see if we have a PDF file somewhere. I think in one of the previous code labs, I had given that to you. Let me just open that repo. One second, I'm just opening that repo. It's on another window, that's why you're not seeing it. Just give me a moment. I think it was in Dark Data Agent Chat, if I'm not wrong. Let me open that here now. Okay, where is the repo? Bucket setup. Yeah, it should be here, this repository. Okay, so this was the first code lab, first session's code lab. I'm just telling you to see the recipes for the most recent test that we did, which is Infra Vanilla Flash. Infra Vanilla Flash. If you open that, I'm opening the PDF. You can just watch, or you can also go to this repo and check it at your end. If you scroll down, it has almond for sure. What else did it say? Tree nuts and almond. We don't know where it took tree nuts from. What do you think it is? Is it aura, lavender, lecithin? Pulsar, vanilla powder, stellar. We can check that. We can check if suppliers, if any of the supplier contains that, we can check that. Pulsar, no. Comet. I mean, almond is a tree nut, so that's one thing, but let's just check. No, that's not it. Also, there we go. Hyper vanilla oil is another PDF which is present in the hyper vanilla oil. As you can see, is one of the ingredients of infra vanilla flash. And I open hyper vanilla oil, and apparently this one contains tree nuts, which is an allergen. And you know what? It's not even identified as an allergen, which, oh, it doesn't contain tree nuts. How can it not contain tree nuts? Tree nuts, almond is a tree nut. Interesting. Okay, we'll have to go through each one to see where it found quantum. Did I check everything? Comet. Yeah, I think I checked everything. Solar. Oh, I'm say checking in the wrong place. Sorry. Hyper vanilla was one thing that I found. Another was false stellar. Stellar I already checked, I think. Anyway, we can go through it and see why it has. If you backtrack the query that we found in BigQuery, we'll probably be able to see which of those ingredients contains tree nuts and how it identified tree nuts. So we'll come back to that in the end. If we have time after answering the questions, we'll get back to that. But yeah, as you can see, even the things that we are not able to observe and see, the agent is able to catch from the items that we list here and ask for allergens. There's one more question in the code lab in the last step, which is ultimate test step, which is asking to order 2 midnight swirl for Alice. Just copy that, or just say order 2 vanilla swirl for ABC, and you should be able to see that the data entered into your AlloyDB. In my case, I have it in my AlloyDB database, but I'm running the Noble one, so it will just insert into your CSV. It is not actually going to AlloyDB right now because you are not using a billing account one. I'm using it, but you won't be able to see. However, your order has been successfully placed, and you should be able to see this response from the agent. This is not hard coded again. It's all coming in from the tools. It's just that what the tool does is exclusively using CSVs in the case of no billing account. But if you're using billing account and you're using MCP Toolbox, it will actually go to your database. In my case, I can show to you from the test I ran. If I query the live orders table, you should be able to see that Alice's data has been inserted on 1st June, right here. Cool. So that's pretty much it. That's it for the application. Since you did not do any AlloyDB cluster instance deployment in the previous session, and in the session also, you don't have to do this step. But if you did create an AlloyDB cluster instance in the last session, in preparation for this session, please feel free to delete your cluster instance right now. You don't want that you to use up your free credits or any credits that you may have from your own previous experiences. So don't keep these instances unless you plan on building on top of that. You have a way to either pause it or delete it completely. I would recommend deleting it. And how many, show of thumbs, how many of you completed this step? Yes, you can actually enable thinking. You can also set up callback trees in your agent to explain why it has given a certain answer. Endpoint URL is not required, Amisha. You can just run the, you should not run app.py. You should run app-nobuild.py. How many of you were able to successfully test it? Sorry, I missed that. Okay, I'm assuming you all were able to successfully test it. The API key to dot, you can just paste it, that's all. Paste the API key. If you go to the .env file, you just have to paste it. Where is the dot? Yeah. Right next to the equal sign, replace the stars. In the .env file, just replace the stars with your API key. If you can't find your .env from the Cloud Shell terminal, editor, from the Cloud Shell editor, go to view menu and then click toggle hidden files. You should be able to see your .env. Thank you for confirming, Jashwant. Uttam, there are multiple ways to enable agent reasoning. You can actually design a tool for agent reasoning, or you can include callback tracing to see which tool has given this. In case your answer is lying in the essence of your queries, those are the scenarios where you have to custom design how to backtrack. Like in our case, the detail is in the query because our query is so detailed enough to join these multiple tables that we extracted from. See, ideally, one more thing which I want to call out, MCP Toolbox has a tool, inbuilt inherent tool called query data. This query data, we are not using that today in our session, but it's already live, it's already GA. You can use this query data tool of MCP Toolbox to automatically write these queries for you based on natural language question. So remember how I showed you the tools.yaml file, the detailed query that we have in the tools.yaml file. So imagine that there is a situation where you don't know what the user might be asking. It can be anything. Like I can say, for instance, if I ask volcanic, where did you find the ingredient list? Where did you find this? I can ask this question to this agent. Maybe it won't be able to answer because it is able to see, okay, which ingredient of this product has this. You can, maybe this is by the virtue of the natural intelligence of your agent, it will be able to answer, but the tool is not devised to support that level of intelligence in this session. But you can definitely do that. But the reason why I brought up query data is some folks might be interested in not writing queries for corner cases where you won't know, like in this scenario, you didn't know that the agent didn't know that I'll be asking questions like, why did you pick this allergen? Which ingredient had this allergen? Show me everything. In which case, you can use query data to formulate that level of corner case queries. It directly converts natural language into SQL and runs and brings the data back to you. It is available natively in MCP Toolbox, which you can leverage. But we are not using that today. But you can. It's just a REST endpoint which helps extract information based on natural language user questions. It is the same session result link for everything, Yugender. Now, I just want to address one thing. Let's go to that BigQuery or the AlloyDB query and see where it found this, if you're interested. Otherwise, I can take more questions. How many of you successfully submitted the result? Thanks for confirming. If API key is not valid, try another API key, Sai Venkat. You can generate a few API keys. This is only one app they are running, so you can run it in the default port that it takes you to. You would be able to see it in app.py or app nobuild.py. We have asked it to run it in 8080. That's pretty much it. Now let's go ahead and ask, let's go ahead and find that BigQuery query for a second. If you remember, we had that query from last time. Let me just copy that. You don't have to take that. If you have your BigQuery dataset still, just go ahead and find it out for yourself and tell me if you get there sooner. I'm going to take that query from Dark Data Code Lab, the first session's Code Lab. If we go to the SQL in step number 9, I'll copy that to BigQuery. So I'll share that screen 1 second. Yeah, here I am. So my ingredient that we are concerned about is, which one was that? Infra Vanilla Flash. So I'm just going to copy that and find out where it found tree nuts. It's running. Oh, because there is a way to, in BigQuery, to ignore case, but I forgot what it is right now. So I'm just going to do all caps and try. Oh, there we go. The Comet almond powder has tree nuts. And almond. How does it know that? How does it know? I'm just looking at Comet almond powder, where it is. Just give me a second. So in our BigQuery query, we are joining consists of and product and ingredient, and contains allergen. So one of the ingredients that is apparently the culprit here is Comet almond powder. So what I'm going to do is It's not product name. What is it? I don't know. Let's see. From ingredients table. I'm just trying to see where it found the tree nut. I'm just obsessed with this because I'm curious whether it actually took it from the PDFs or not. Oh, so sorry. I want to find out what this is. Ingredient name. It has 3 different ingredient IDs at different places. Contains allergen. Sorry, this is my last try. I promise I'll let you go in 2 minutes. Okay, Comet almond powder is here. But remember the other 2 IDs that it had? What was that? Ingredient. Okay, these are the names we want. Contains collagen. Comet almond powder, 4-5. Okay, now let me see which one has this. Sorry, this is ingredient ID. Feel free to drop off, guys, if you're done. I'm just trying to analyze why it said tree nut. I'd be surprised if. Okay, there we go. This ingredient ID has tree nuts, and this ingredient, interesting. 455-50-6 is used in one of the products, which is not the product for which the user manual for Comet vanilla powder is given. It's being used by some other user manual, which has the same ingredient and uses the or it contains the allergen tree nuts. That is how deep the links are. Interesting. So it is not, we know that it's not hallucinating because this data is actually coming. There we go. For POW also has tree nuts. So the same ingredient is present in multiple files, but they're identified differently, and the user manuals are probably different for each one of those. And it is essentially leaving it with an unknown ingredient, which is tree nut. If you happen to find some hallucination or something, please feel free to let me know, because from what I'm looking at, it looks like data is coming in from the PDFs, and it is so deeply structured that we are not able to like we won't be able to physically tell unless we open every single ingredient of every single product out there, because there could be a product that uses say almond powder, for example, which contains a specific allergen, and it's not called out in that particular user manual, but the same product can be referred to as containing allergen, say soy or tree nut, in some other ingredient of some other product, which is a mismatch. But the safe bet there is to say that this product contains allergen. So I really appreciate that response. However, if you do this research at your end in the next few days before the session ends or season ends, and let me know if you find any discrepancy there from the data and what you found. The output is same, but it is same for across our sessions, because to keep it consistent, to know that we are doing the right thing, please feel free to change the input and get your agent to do something else, add new tools. The reason why we are sticking to the same use case is to connect the dots and tell a correlated, a coherent story, as opposed to what we do generally. We have multiple speakers, so sometimes I like the idea of letting the speaker choose their own use case. But this time I was set on bringing up something end to end. And that's why, if you notice, I'm the speaker for all the 5 sessions, so that I'm not forcing someone to do this use case as my interest. That's exactly why you have to sit and listen to me for all 5 sessions. That's sad, but yeah, this is the reason. The last step, Kaim, is just running the application. You will have to deploy the dependencies. If you go to step 7 in the code lab, there is pip install -r requirements. You have to go into the project directory, the root folder of your project, and then you have to install dependencies, and then you have to run the Python app-nobuild.py. It's there in that no billing account box. Instead of running app.py, you have to run app-nobuild.py, because it's a slight difference in how the agent is talking to the tools because of billing account absence. That's pretty much it, folks. So if you ended up submitting the results, that's great. We are over time. So feel free to reach out to me on LinkedIn or anyone else for any further questions. Tomorrow, we will be evaluating the agent that we built today in 2 methods. One is the mathematical, like quantitative LLM approach, quantitative agentic evaluation approach, Vertex AI approach. The second approach is the manual LLM brain approach. You will be able to do one no billing account requirement, which is also made available for tomorrow. So please join in if you're interested in agent evaluations, and followed by the last session, which is my personal favorite. I'll talk about that tomorrow. Yes, Rashiraj, you can ask your question. I'll take one question, and then we'll go. It is dynamic, Shiv Shankar. It's not hard coded. What do you mean? Which is hard coded? The data is not hard coded. It's actually made available in CSVs, because you don't have access to the database. You didn't create the database right now. You can do it if you want, if you have a billing account for Alloy DB, but BigQuery you can easily create. We did that in session 1. Sonia, that's a great question. The agent can identify allergens for a specific product, but it cannot list products containing a specific allergen. Why? Can someone tell me why? To Sonia's question. Exactly. The straightforward or the simplest answer would be because you didn't write the query in the YAML file, meaning we have written only 2 tools. One is find allergens for a specific product and place the order. Those are the two tools we have created. You can create tools to identify all products for a specific allergen, or you can use the query data to you convert natural language. Any user question can be translated, or you can give the agent access to non PII or non-private data or non-confidential data, and make the agent make the decision for you. You can make whatever you want available to whatever you can with security and privacy and compliance, everything adhered. Whatever your agent wants, you can expose it to the agent to make informed decision, or you can use informed tools from MCP Toolbox to handle those corner cases or any cases like that, Sonia. In our case, we wanted to keep it simple, so there are only two tools that we have implemented. It's not a limitation of LLM, it's not limitation of the framework, not the integration layer. It's the limitation of the use case we have designed for today's session. Why don't you try that feature out, Sonia? Show all products contain peanuts. That's a great feature to submit a pull request for. Risharaj, I'll help you with that, updating your answer. Usually in 3 submissions, you should be able to get it because a lot of people were able to submit. If it is still not accepting, just send me your email address over LinkedIn. I'll make sure your response is amended. All right, folks, thank you so much. It was lovely talking to you again. I hope to see you all tomorrow in agent evaluation for the Froyo agent validation, evaluation system. Go ahead and submit the results for today's session. It's pretty straightforward. The screenshot is in step number 7. The last screenshot in step number 7. This is the one that you need to submit. Please do. Thank you all. See you soon tomorrow. Bye.